In this episode, we will focus on intrusion detection and prevention on our router. We will use Suricata for that. There are not many videos about Suricata online, and I will try to cover many of the gaps that you can find in the existing videos, including, for example, what are the use cases of Suricata, how you can use Suricata in a lab, how to create a panic mode that we can start when we are under attack. And if you follow the video to the end, you will see many of the best practices of using Suricata in your Devlab. Now, this is the file, the main file for the role that installs Suricata. We see that we get Suricata from the apt repository since we are using a Debian router right now. We use Suricata update, the update tool, to enable a few sources in Suricata. And these are the sources that we enable. First, we enable the default source, the emergent threat source. Then we have these sources that are free and you can just subscribe to them for free without authentication. And when we have the router build complete, I will show you how to get the list of sources. Then we update the rules from these sources. If we are running in panic mode, we have a variable that specifies that in the variable file. So if we are running in panic mode, we run the panic mode tasks. Other than that, we restart Suricata and enable it. Now, this is an install of Suricata of the router, of the entire router running right now. And this is the variable file. Basically, for this, we added some power to the router. So we increased the RAM to 496. I think after testing 248 is enough, and we need 2 cores. I am using 2 Zen 3 cores with 2 GB of RAM would be enough, and I'm using a connection, an incoming connection of 1 GB per second. If you are using 2.5 GB or like more, you might need to use more RAM or more CPU. Now the router was installed, but before we go look at the router, I want to show you the panic mode tasks. So in panic mode, what we do is we make a backup copy of the rules, then we enter the rules, and we change each alert to drop. Then we change the way the Suricata service is run. So this is the running Suricata as a service, and this is a systemd service. We make it run in the NFQ mode. And for that, we use -q and then a q number. The q number here is 0. And we will use the same q number later on when we configure firewall rules. And since we are changing a systemd service, we reload the systemd daemon. And we continue running the services. And you see after that, the Suricata service is restarted, which should enable Suricata in panic mode. Panic mode requires changing the firewall rules so that you can pass traffic to Suricata, pass all the traffic that you want to analyze to Suricata. So for that, in the router configuration, nftables configuration file that we created a few episodes ago, we add a chain here. So we just create a chain intrusion prevention Suricata, and we count the packets. We tell them to go to the queue, and the number of the queue is 0. And this bypass here is important because this tells the nftables that if this queue is not working for some reason, this is a queue that is part of the user space. It's a service that we create. It's not part of the kernel, and the nftables is running in the kernel space. So this tells the kernel if this service, or if nothing is listening on the queue number 0, you have to bypass that. Bypass means rendering an accept verdict on all the packets. Now this is risky because we are passing the forward to Suricata before drop. So we need to make sure as much as possible that Suricata is running and the kernel has a queue to forward to. To do that, we need to install Suricata and make sure it is running before we configure firewall rules in the Linux router. We have installed a router right now, so I'll reload the window here. We first look at the Suricata configuration file, and the configuration file, the most important thing is Here I am accepting the defaults, so I'm not changing the defaults. So for the defaults, homenet is these IPs, which include my IPs, and external network is anything that is not homenet, and that is fine for me. After that, let's look at the rules. You see this rules folder here. This includes all the rules that Suricata downloaded, and suricata.rules file. This is a huge file, hence the use of memory. And if we open this rule, we see that lots of alerts, alert, and we see here a rule that I highlighted. If you look at this rule, for example, ET policy, apt user agent outbound likely related to package management. So this could be either somebody trying to download to update packages on a system, or somebody trying to impersonate something, trying to download packages on the system. Suricata, when it sees this traffic, it gives us an alert that this type of thing is happening here, and that alert would go in ev.json. And here we see that all the flow you see. For example, this is a flow rule, a flow event. This is a TLS event. This is a flow event. And let's see if we have any alert right now. If we don't have, we need to generate an alert. So I look for alert, and I don't have any alerts. So let's generate an alert in Suricata. And I am logged into our WordPress development container. If I do apt update, there is some latency here because the traffic is going through Suricata for the first time, but we are able to update. Now, if I come back to Suricata and look for alerts, I see now I have alerts. So we managed to generate an alert now. This alert comes from this rule here. And if we convert this alert to drop right now and restart Suricata, all this type of packets will be dropped. In Suricata, we have this event log, which is, as you see, JSON. So each line is a JSON record. Suricata has multiple types of logs that it can generate. It can generate logs in this EVE event JSON file. It can send logs to a database. It can send logs to MongoDB, to Elasticsearch, where we can put Kibana in front of it and have a nice dashboard for that. And there are open source tools to do that, but they are outside the scope of running Suricata on the router. We have this fast here, which shows us the important logs. And here we see that we had some warnings. We have a statistics log also. And here we can see like many statistics that Suricata has generated. And you can see that I have quite a lot of ICMP traffic related to IPv6 because I'm testing IPv6 in my Devlab for a future episode. We restarted the router. I did not convert this to true. I need to convert this to true and run the role again. Sorry. Now the rules were edited, and now we have drop instead of alert everywhere in this file. So by now, I think Suricata has been restarted, and yes, so we have done changing the rules. So if I go back here and I run the same command again, nothing, no header, nothing, like the packets are being dropped. And if I look at Suricata's log, I look at fast.log here, I see that dropped. We have dropped some packets that were going to this user agent, and we are running now in IPS mode, and we have blocked traffic to like many of the things that we might consider important or like trivial in a normal lab. We do that only in panic mode. So basically, what we have done so far is we enabled panic mode, and you see how panic mode is risky. You enable it only when you are under attack. it blocks so many things that might be trivial or you might consider false positives. To avoid this type of issues and blocking trivial connections, normally what you need to do is to create a baseline. In a baseline, you override these rules, you create new rules that explicitly allow specific types of traffic. For example, if you have a host that has that is listening on port 443, so you have an HTTPS service running on port 443, then the firewall can block any traffic to any other port. You don't need Suricata for that. But the firewall will allow any traffic, any TCP traffic to the port 443 on that port. The firewall does not do the packet inspection to check what type of packet that is, but Suricata can do that, and it can look through the packets and can identify the protocol. So if you are not sending HTTPS traffic, Suricata can block that. Suricata can detect file names, for example. Suricata can detect the destination IPs also. So if you have an IP that is on a certain bad reputation list, Suricata can integrate that. We have a list of aggressive IPs that we automatically block in the rules. So the most important thing for you is to create, if you want to run Suricata in production, is to create a baseline. And for that, you need to choose the rules you want to allow to pass and the rules you want to drop. There are 4 basic actions that you can put here in the rule. Here we can have pass, drop, reject, or alert. And for reject, we can have either reject source, so we send an ICMP packet to a source telling them that your request was denied. Reject and reject SRC are the same action. Or we can have reject DST. We can put here reject DST, and we inform the destination that this packet was denied for some reason. Or we can send a packet to both destinations by doing reject both. So basically we have here either accept, drop, reject SRC, reject this DST, reject both, and alert. And the execution of rules in Suricata follows the weight of the rules as you specify them in here. This is the action order in Suricata. So first, all rules that have pass action will be processed. Then all rules that have drop action will be processed. Then all rules that have reject action will be processed. And for each of these, if we have a verdict, pass or drop or reject, the action is taken and no other rules are processed. For alert, we keep processing rules until we finish all the alerts. This allows us to create new rules and add pass or drop outside the rules file that Suricata maintains using Suricata update. So we can create a new rules file and we can include the rules file here. So if I put suricata.rules, I can add a new rules file here called local.rules. And I create a local.rules file here, and I start adding the rules for my own network. Now the rule format is simple. You have the action, then the protocol that you are running this action against, and the documentation shows the list of the protocols and the rules and explains everything about here. Then you have the source, and in the source you have, of course, the source group of connection and the IP itself. So if you have something coming from the home net and on specific IP or any IP to an external network on a specific IP or on any IP, and then you have the rule options. And in the rule options, you specify what you like, what you want to do and to log, and like everything here that is related to why you are doing this action on this specific packet. Here you can add also deep packet inspection rules like content. You create your own rules to match your own network, and you put them all in a specific folder that will not be affected, that will override. For example, if you have accept verdicts, they will override any drop verdict that you might have here. So if you enable panic mode in our setup here, if we enable them, anything that we have deemed acceptable will still pass. Basically, this is what you normally would do in to create a baseline in Suricata. So I cannot stress enough that it is important to create a baseline for your Devlab or for your system if you want to put Suricata on your router on the edge. It is very important to create a baseline of the traffic that you want to pass, and it is also very important to be ready to face an attack and to be able to press the panic mode, and within a few seconds you have redeployed your router and you are blocking anything that is outside your baseline. Suricata can be used in IDS mode, so intrusion detection mode, as we have seen, and you depend on the eve.log.json log file. It can also be used in prevention mode when you run it in a net filter queue mode and you direct traffic to it from NF tables or from IP tables if you have IP tables. It can also be used in appliance mode, and in appliance mode it's basically an advanced use of IPS mode. It's as if you cut a line and you put both ends of that line inside Suricata. In this case, you need to have two ports, and what Suricata will do is it will copy the packets that will pass from one interface to the other. So for each input, you will need to have two interfaces, and these two interfaces will be sort of like connected via Suricata. This is how you use Suricata as an appliance, and there are like enterprise appliances that use Suricata, and there are also subscription services that these appliances can download threat intelligence from and configure automatically, and those are paid services. Suricata is a wonderful tool, but it has some limitations. The first limitation is Suricata can detect suspicious traffic, some types of suspicious traffic, but it cannot detect all types of suspicious traffic. For example, if somebody is trying to crack a password, a brute force attack on a password on your site, and they are sending a password attempt every 30 seconds, for example, Suricata will not be able to detect that, because normally, like a password, you would allow people to log into your to SSH from a remote connection. And if that remote login is normally allowed, Suricata will pass the packet. There is no reason to raise an alert or to drop the packet. However, what you need is something that looks at the log files and detect that, like, we are getting repeated password cracking attempts from this IP, from a specific IP or from multiple IPs, and those IPs are normally what you need to block. You don't need to block the connection, you need to block the IPs. Suricata falls short on that type of network protection, but that is part of reactive security. Suricata excels on proactive security, on preventing something from entering the network, from preventing something from happening inside your network. In the next episode, we will add a reactive security tool to our router, and after that, our router will be ready to face the internet. What remains to make it an industry standard router is some advanced configuration and IPv6 support in all our models, in DHCP and in DNS and everywhere. But if you are using IPv4 only, once we add reactive security, we will be ready to test our router on the open internet. And that is what we will do in the next episode, reactive security on the router. I'd like to invite you to check my AI content as well. And in AI, my recent video was about the real risks of AI. So it discusses why some people are afraid of AI taking their jobs and how that is not the real risk of AI on everybody right now. And that is an open discussion, and I'd love to see some feedback around it from the audience if you are interested in the discussion, in the social discussions around using AI in our society. I will make a pause before launching season 2 because I'm still not decided on what the platform is. As I said before, my intention is to run it on OKD, which is the open source distribution of Kubernetes. And it's basically open source OpenShift, the Red Hat OpenShift cloud, but in open source. And I have a good experience in that, especially using DevOps on the OKD cloud, but I am still not 100% decided on that, but I will see what I will come up with. Of course, your ideas are welcome. If you have any ideas on what hypervisor you want to see, or whether you want me to use OKD or any other platform, please let me know in the comments. I would like to thank all the people who follow me on YouTube, GitHub, Medium, and the other platforms, especially the people who leave me comments on these platforms. These interactions with the audience give me the feeling that my videos provide some value to other people, and that gives me the motivation to do more videos for you. If you think that my videos are useful, or that my code provides any value to you, please let me know in the best way possible for you. As usual, the code for Suricata for this episode will be in the GitHub repository of the series. And a link to that repository will be in the article, and the article link will be below this video in the description. There will always be an open pull request in the repository in GitHub, and the code I wrote right now for this episode will not be merged until a pull request for the next episode is published. So if you have watched this video, maybe you would enjoy looking at the code. You will see it in a pull request until a new pull request is merged. I welcome comments, code reviews, and any type of feedback that I get on GitHub. Please feel free to fork the repository and to modify it to match your own Devlab. This is work under the MIT license, and basically you can do whatever you want with it. You might be interested in the previous episodes where we installed the firewall on the router, where we installed Kia DHCP and bind DNS on the router, or in episode 3 where we configured the entire Linux router. And if you are not happy with a Linux router, maybe you like my episodes about the RouterOS router and how we did all the configuration, we automated all the configuration using Ansible. Please follow my work, and let's meet in a previous episode or in the next episode.